Are there open-source platforms for quantum hardware experimentation? If you have ever wondered whether there are open-source platforms for experimenting with quantum hardware, you are in the right place. Let's break down the details to give you a clear picture. Yes, there are several open-source platforms specifically designed for quantum hardware experimentation. These platforms offer tools that help control quantum devices, design quantum processors, calibrate systems, and run experiments on both real and simulated quantum hardware. To start, quantum hardware experimentation involves working with quantum bits, also known as qubits, and their control systems. Open-source frameworks provide software that interacts with quantum devices at two levels: pulse level, which deals with the physical signals controlling qubits, and gate level, which focuses on logical quantum operations. One notable platform is Quantify. This is a Python-based framework that is hardware agnostic, meaning it can work with various types of quantum devices. It supports data acquisition and control of quantum hardware by combining pulse-level and gate-level qubit control. Quantify is built on top of Qcodes and is maintained by spin-offs from Qtech. Another important tool is Qiskit Metal. This toolkit is designed for superconducting qubits and allows users to create blueprints for quantum processors. It helps in designing the hardware layout and simulating electromagnetic properties that are relevant to qubit performance. Then there is pyEPR, which was originally developed at Yale for designing superconducting qubit processors. Many research groups use it for quantum hardware design, as it assists in modeling qubit parameters and interactions. QUAlibrate is another open-source framework that focuses on automating and optimizing the calibration of quantum computers. Calibration is essential for tuning quantum devices to achieve high fidelity. This platform allows researchers to create reusable calibration protocols and share improvements, significantly reducing calibration times. Cirq, developed by Google Quantum Artificial Intelligence, is an open-source framework for building and experimenting with quantum algorithms on near-term quantum processors. While its primary focus is on algorithm development, it also supports interfacing with quantum hardware. The Intel Quantum Simulator is a high-performance quantum circuit simulator that is open-source. It allows users to test algorithms on simulated qubits, which is useful for validating hardware control software before deploying it on real devices. Qibo is another open-source framework that supports quantum simulation, hardware control, and calibration. It enables experimentation with both simulated and physical quantum hardware. Additionally, there are tools that provide remote access to quantum hardware. For example, ColdQuanta offers a Bose-Einstein condensate quantum system that can be controlled via the cloud, allowing for remote experimentation. These platforms often include software libraries, hardware design toolkits, and calibration tools, creating a comprehensive ecosystem for quantum hardware experimentation. They enable researchers, developers, and engineers to design, control, and optimize quantum devices collaboratively. Practical applications of these open-source platforms include designing and testing new quantum processor architectures, developing and validating quantum control sequences, automating calibration routines, and running quantum algorithms on real or simulated hardware. In summary, open-source platforms for quantum hardware experimentation are actively developed and widely used. They provide accessible tools that support the entire experimental workflow, making them essential resources for advancing quantum computing research and development.